Welcome back here to the third video of this series that I'm keeping on sending you. I hope you're copying the notes and doing those examples. When I come next week during the Easter holiday, I expect to see that work. Now we're covering a new concept of Pythagoras theorem in trigonometry, and from Pythagoras theorem we know it applies to a right angled triangle, and if that's our right angled triangle with adjacent x opposite y, hypotenuse r, then there is an angle along the OX in the anticlockwise sense, which is theta. Now from Pythagoras theorem we know that adjacent squared plus opposite squared is equals to hypotenuse squared, that is x squared plus y squared is equal to r squared. We also realized from the same triangle that if we were to get the sine of theta, it will be equal to opposite, which is y, over hypotenuse, which is r. So we make y the subject because we are going to substitute it in the Pythagoras in the formula that we obtained from Pythagoras theorem. So when you make y the subject, you come up with y is equals to r sine theta. You also observe that from the same triangle you can make x the subject by getting the cosine of theta, which is adjacent x over hypotenuse r. Therefore x will be equal to r cos theta. Now we shall call this other equation our equation 1, y is equals to r sine theta, and x is equals to r cos theta as our equation 2, and we shall call the equation we obtained from Pythagoras equation A. Now we're going to substitute equation 1 and 2 into equation A. And so when you substitute those two equations into the equation A, you'll obtain that particular expression, r sine theta into squared plus r cos theta into squared is equals to r squared. When we expand that expression, you come up with r squared sine squared theta plus r squared cos squared theta, which is equals to r squared. Now on the left hand side, you realize r squared is our common factor, so we pull it out and remain with sine squared theta plus cos squared theta inside the brackets, which is equals to r squared. Now when we divide on both sides r squared by r squared, you'll obtain sine squared plus cos squared theta is equal to 1, which is our first equation from the Pythagoras theorem. Now the other two equations are obtained from that first one. So in the first case, we get that equation sine squared theta plus cos squared theta is equal to 1, and divide all through by sine squared theta. And so when we do the division on both sides by sine squared theta, you'll obtain that sine squared theta over sine squared theta is 1, plus cos squared theta over sine squared theta, that is cot squared theta, you remember that. And 1 over sine squared theta will give us cosec squared theta, and that gives us our second expression. Now the last expression, finally, we still obtain it from the first one, sine squared theta plus cos squared theta is equals to 1. This time around we divide through by cos squared theta, and so when you divide through by cos squared theta, you realize we now come up with sine squared theta over cos squared theta, giving us tan squared theta, cos squared theta over cos squared theta, that is 1, and 1 over cos squared theta gives us sec squared theta. And those are the three equations that we obtained from Pythagoras that are going to be very important to us as we continue this particular series. Hope to see you in the next video. Thank you. Please remember to subscribe to my channel, Machese Dan Machese, for more videos on YouTube.